Hello, and welcome back to Cost Accounting. I'm your host, Dr. B. We are in week 4 of our cost accounting course here at UMGC. Uh, Today, we are going to be discussing two key concepts in cost. The first one's called process costing. We learned a little bit about process costing, and we had a few conversations around it in the previous session. And the second concept we'll discuss today in depth is going to be activity-based costing, which, in my opinion, is probably the most accurate form of applying factory overhead. And we'll talk a lot about that. Uh, so, as we learned last week about process costing, we learned that process is continuous. Process is continuous. What do we mean by continuous? We're continually adding cost at each step of the manufacturing process. And the manufacturers that use process manufacturing are what we call processors. An example of a processor would be a dairy farmer that is continuous processing of dairy milk or dairy products. Another example of a processor would be a food processor that makes chicken or beef or vegetables. It's continuous. It's a continuous process. There is no stopping, and it's not done based off of customer orders. Another example of a process manufacturer or processor would be ExxonMobil, Chevron. Uh, I'm just thinking of some of the names of your companies you selected. ExxonMobil, Chevron, other oil and gas companies. Those are process manufacturers. It's continuous. It's continuous. And in process manufacturing, we have multiple departments that the product moves through. Think of a conveyor belt or an assembly line or a series of machines. And the product moves from one machine to another machine to another machine, and then ultimately to packaging. That is continuous. That is a process. And in process manufacturing, we have multiple departments that add to the process. For example, in Department A, where the raw materials are introduced into work in process, Department A begins that manufacturing process. So an example of that would be, let me think here. An example of that would be the mixing department for an ice cream manufacturer. And they're mixing the raw ingredients, the raw materials. And in Department A, in the mixing department of an ice cream manufacturer, they are adding direct materials from the raw materials inventory, but they're also adding direct labor and a little bit of factory overhead. Then when the mixing department, Department A, is done making the ice cream, done mixing the ice cream, they send it off to Department B. Down the assembly line it goes. And Department B, they are I don't know. What's next after mixing the ingredient? They probably do some other process to it. They add ice. I don't know. and so they're adding some more direct labor and more factory overhead, and then when they're done with their part, they send it off to Department C. And Department C, they get the ice cream after it's done with the ice in Department B. Department C, what they do is they drop the ice cream into the containers. And in Department D, after the ice cream is in the containers, Department D, they seal the lid and they package it. They put it into the boxes. and move it over into the cold storage unit ready to be sold when it goes to a finished good. And that is continuous. It's done regardless of customer orders. It's a continuous flow, right? And so we can see that at each department level within work in process, we're adding more direct labor and we're adding more factory overhead. Those are our costs, in addition to, of course, the raw materials that were introduced in Department A. And so what happens is that as the product moves through each department, we total up the direct material, direct labor, factory overhead for each department. We total it up as it's moving through the assembly process, and we keep adding it to that respective product until it reaches its finished stage. And that is the concept of a process manufacturer. And we'll dive a little bit deeper, of course. What we learned about last week, in comparison to what we learned last week we learned a lot about job order manufacturing, job order costing. In job order costing, they make more specialized products and batches, and it's based off of customer orders. And this is an example of that is stereo equipment. Right? Let's take a look at the different types of companies that we consider to be process manufacturing and job order manufacturing companies. And you can see a trend, right? You can see, kind of get an idea of the type of companies that are processors. Pepsi, Coca-Cola, Alcoa, all of the oil companies, all of the gas companies, Intel, Apple, Hershey's. These are a lot of these companies are companies that you all had selected for your 10K project. And those companies that continuously manufacture regardless of customer order, we call those process manufacturers. Because they continue to process the product into a finished good. And it's done regardless of customer order. And we compare those companies to other manufacturers that produce based on customer orders. Example would be, well, Disney's more of a service company than it is a manufacturing. Disney has a small, well, maybe not as small anymore. In fact, I won't be surprised if they move out of service and more into manufacturing. But Disney, we know that they have the theme parks. The theme parks is a service business. But their movie division, that is more on the manufacturing side. But because Disney is primarily a service business, we don't consider them to be a true manufacturer. So there's a small nuance with Disney. Nike makes athletic shoes based off of their customer orders. Nicholas Design is a golf course design and manufacturing company. Interesting company, I guess. Of course, that's done based off of specialized customer orders. Tennessee Heritage is a log home manufacturing company. They make log homes based off of, you guessed it, customer orders. Advertising firms, those are done based on customer orders. And they're manufacturing. Well, advertising isn't quite manufacturing. Well, I guess it could be if they all they do is billboards. That's technically manufacturing. But we can see the comparison, right? We have a really good understanding of the difference between process and job. Process, they do things continuously, regardless of customer order. And job order, they do it based off the customer's job. Both of them record and summarize product costs. They allocate factory overhead to products. They provide useful information for decision making, classify product costs as direct materials, direct labor, and factory overhead. And they both utilize perpetual inventory for raw materials, work in process, and finished goods. So they have those elements in similarity. They both utilize these same things. But again, the primary difference between the two is when we talk about process, we talk about continuous. When we talk about job, we talk about customer orders. And that's really the crux of it. So let's take a look at our examples. Earlier, in our last session, we discussed the concept of job order cost system from the example of Legend Guitars. They manufacture and sell guitars. The job order cost system utilizes, as you know, job cost sheets, where we, based off of the customer job, we add up the direct materials, direct labor, factory overhead that's used for each job to create the finished good. That part we got. We understand that. Process cost system, a little bit different. There's not a specific job that they're trying to fulfill. Again, it's continuous regardless of customer orders. So in the example here, we have an ice cream manufacturer, and again, you could use something like an oil company that drills oil from the ground, and then they refine it, and then they refine it again to create different products, and then they package it in a container and ship it off to the customer, right? That process is what makes them a process cost system type of company. It's continuous regardless of customer orders. And so the example we're using here is a ice cream manufacturer. The products, the raw materials that we're using here are dairy, milk, cream, and sugar to make ice cream. We take those raw materials, we put them into work in process. Within work in process, we have multiple departments. And we can see the flow of the materials. Think of like the physical flow. How does this flow work? Well, it came out of direct materials, went into the mixing department, then it went into packaging, and then became a finished good. Mixing and packaging are individual work in process departments. Within those departments, we have direct labor and factory overhead, and a little bit more materials, right? So instead of using the job cost sheet that we learned about last week, we are using the respective work in process accounts for each department. Okay. And so in that, the way it works is we take our our raw materials, we add in, we take that into the mixing department, which is the first work in process department. Then we add in direct labor from the mixing department, and we add in some factory overhead from the mixing department. Once the mixing department is complete with their part of the process, the ice cream moves down the conveyor belt, I think. We'll pretend it's a conveyor belt. Or it gets put on a pallet jack and moved to the next department, right? And in that process, the costs, of course, go with the product, and they get transferred. Yeah, transfer is the word I'm looking for. The costs get transferred from the mixing department to the packaging department. But you're like, oh, Dr. B, but they're both work in process departments. Yeah, you're right. They are both work in process. But the concept here is that as the product physically moves through each process, the costs go with the product. Okay. And so when it makes it to the packaging department, we add more direct labor from the packaging department. We add more factory overhead from the packaging department. And then we add more direct materials, the package, right? And then when that process is done, we transfer it out of packaging department with all of those costs that have accumulated from both the mixing and packaging over to finished goods. And it becomes the total cost of a finished good. And so if you think of it from the perspective of a physical flow of a product in an assembly line or in a process, we can see how cost continues to add to the total cost of a product as it moves through the process. What was I going to say? I was going to say something very interesting. Now, what was it? I'm sorry. For some reason, it just escaped me. I'm sure it'll come back. Okay, I remembered. So it's continuous, right? So when you think of a continuous process, when the work in process moves from one process to another, meaning we're moving the product from mixing to packaging, there's more raw materials going into mixing at the same time. And then it goes to packaging. And then there's more mixing and more packaging and more mixing and more packaging. It's continuous, right? So it's a continuous flow. That's why it's a process, right? And that's the general concept of process costing. So as it moves through the process, it accumulates. Was that the word I used? Accumulate? I think I did. Accumulates in each department. And which obviously is different than job costing. Job costing, it stays on one customer job order's cost sheet, right? Whereas in process, it goes onto the ledger for each department, not for each job. So it goes onto the department's ledger, gets transferred to the next department's ledger, and then gets transferred into finished goods. Whereas in job order, we look at a work in process at the end of the accounting period. For process costing, we look at the end of the period and sum the remaining costs of each department. What does that mean? So in job order costing, you know that at the end of the job, or even in the middle of the job, at the end of the accounting period, we simply total up what's on those job cost sheets. Okay. Whereas in process costing, we total up what's happening in each department at the end of that accounting period. So what that means is, looking at our ice cream example, I'm going to continuously have something in the mixing bowl. I'm going to continuously have something in the packaging department. I'm going to continuously have raw materials and finished goods. And so from that perspective, at the end of the accounting period, we simply total up what is in each department. And the way that we do that is we do this thing through allocation of whole units and partial units. And so as we go through this concept, think of, again, the physical flow, raw materials to the mixing department, to the packaging department, to finished goods. The physical flow is what outlines a process manufacturer. That's why we call it a process. And this information that we gather in each department goes onto this thing called a cost of production report. Okay, the cost of production report, it's a summary of the data that each department's responsible for. And these include the units, both partially and whole, that have been completed during the accounting period and transferred out. Well, also partially completed. And so as we prepare this cost of production report, there are a couple of steps. The first step is, of course, to determine the units to be assigned costs. The units to be assigned costs include whole units and partial units. A partial unit is a unit that has not yet been completed. A whole unit is one that has been completed, or the equivalent thereof. The second step is we compute equivalent units of production. So, for example, if there are 16 ounces to a pint of ice cream, we can identify that if there's 16 ounces to a pint of ice cream and the pint is not quite full, then we can assign equivalent units based off of each respective pint or I'm sorry, each off of each respective ounce. And so the ounce would be our equivalent unit. The third step is to determine the cost of that equivalent unit. So the cost of an ounce, right? In that example. And the fourth and final step is to allocate costs that are to units transferred out and partially completed units. What that means is that we're allocating costs based off of the added factory overhead as it's been transferred to the next department. So as we prepare this report, we do this based off of the manufacturing process. Most commonly in processing companies, most commonly, and I say most commonly, we use the first in, first out inventory method because it follows the flow of the process. The first in, first out inventory method, as you hopefully recall from Principles of Accounting 2, is the concept that inventory follows a physical flow where the first unit to come into the process, meaning the first raw materials to come into the process, are the first ones to leave the process. First in, first out. And that is the crux of for valuing the inventory at each step or each department. So in our example, and this is an example of our cost of production report, we have inventory at various stages. Okay. We in this report is for just one department. This is for the mixing department for the month of July. So at the end of the accounting period, we would prepare this type of report. And this report tells us how much material is in the mixing department at the beginning of the month, how much of that original inventory at the beginning of the month has been completed already, which gives us the July 1 inventory. We then, throughout the month of July, account for additional direct materials brought into the mixing department. In our example, 60,000 gallons. We account for the amount of direct labor we've incurred for the month of July. In this example, $10,000. We account for the amount of factory overhead we have applied to the mixing department for the month of July, $7,275. And we identify the total production cost for the month of July for the mixing department, in this case, $90,000. Now, how we got there, you have your beginning inventory, you have inventory that's already been completed, you have your direct materials, direct labor, factory overhead. And the question then becomes, after we've discovered all this information, the question then becomes, what is what's our conversion cost? The concept of conversion cost is the conversion from one stage or one process to another. Conversion means I have these completed units or this percentage of completed units. It became converted because I've added in direct labor, factory overhead. And once I've added in direct labor, factory overhead, it becomes a cost of conversion, converting it from, it basically means converting it from raw materials to a partially completed unit within that respective department. That's what conversion means. We're converting the costs of the process to be transferred out to its next stage. And so what we do is we find the amount that we've transferred to the packaging department, which is the next stage of work in process, or next department of work in process, including the completed units. So in this example, it's 62,000 gallons, and the inventory in process at the end of the month, we have 3,000 gallons remaining at 25% complete, 25% conversion cost. And that information helps management to then, of course, make decisions on cost for that respective department. And it helps us to understand the true cost of the partially completed unit as it moves from one department to another. And so in preparing that production cost of production report, we do that for each department at periodic intervals, typically at the end of each accounting period. That's usually when we do something like that, unless we're doing an audit, or a quality control inspection. Those are really the only two times we don't do it at the end of the accounting period. Well, yeah. Usually just audits and quality control. Those are the only times we don't do it at the end of the accounting period. The units for which the department is accountable for are noted on that report, and the production costs for each department, of course, get allocated, and they get transferred out in partially completed units. When you hear the word transferred out, it means it's moving from one work in process department to another. Transferred. We're transferring it. We're moving it. Again, it's important to think of the physical flow. So that is the completion of the process-based costing. Any questions on process-based costing? Before we move into the most important part of this week, activity-based costing. Also one of my favorite topics. We're good? Everyone's okay with process-based costing? I know we learned some of it last week, more of it this week. There's only going to be a few questions on the homework as it relates to process-based costing this week. There were a few questions that somehow, my friends at Gleim, let me tell you, it's not always easy working with Gleim, as you're finding. One of my frustrations with them is how they organize their content as it relates to building those homeworks and exams. And it's, I don't know how much of it's their fault or my fault or a combination of both or the nature of accounting. But we know that with accounting, there are a lot of interrelated components, and some of those interrelated components translate to how do we identify the difference between job and process costing when we know that there's a relationship there. We know that the concepts are relatively similar. The true difference between process and job costing is simply how it's being allocated. We know that we allocate job costing based off of each customer order. We know that in process costing, we allocate the cost to each department as it moves through the process. So really, the primary difference between the two are just that. But we know that at the end of the completion of the job, we know that the total cost of each product will be the same. It's just it's about how the respective companies identify the allocation of the cost process. It's not so much about, is the cost going to be different? No, the costs aren't going to be different. but the way that they're applied is different. That's what I'm trying to get to. Does that make sense? Or any questions on that? You good? Okay. Wonderful, wonderful, wonderful. Okay, let's move on to my favorite part about this week, and one of my favorite topics. Monica, did you have a question, my friend? Are you okay? You are on mute if you are speaking. I'm sorry. You're okay? You can always type it in the chat too, if you can. You're good? Okay. As always, if you have questions, just let me know. Okay, so activity-based costing. Activity-based costing is the concept of the process. There we go again. It's the concept of allocating factory overhead based on activities. Okay? Activities are job activities. Okay? Like, for example, assembly, that's an activity. Okay? Fabrication, metal fabrication, it's an activity. It could also be a department. Quality control inspections, that's an activity. Setups of assembly lines, that's an activity. There's a lot of different types of activities. I'm just throwing them out there. But we allocate factory overhead based on activity. That's the concept of activity-based costing. Don't worry, we'll get through it. I want to first explain a couple of different methods of allocating factory overhead before we jump into the concept of activity-based costing, to give you an understanding of how factory overhead is applied through activity-based costing. So we know that a product cost consists of direct materials, direct labor, factory overhead. What you hopefully also know is that direct materials and direct labor, we also call those direct costs. Direct cost. The concept of a direct cost means we can directly trace the cost to a finished good. Okay. Factory overhead, which is a special animal in itself, is considered to be an indirect cost. Okay. Because not all factory overhead can be directly traced to a finished good. There are three primary methods that companies use to allocate factory overhead. And we do this based on rates. Rates are what we call the allocation base. And these rates are based on the level of activity, or the primary activity, I should say. And the base can be considered, it could be considered a couple of things. It can be considered total direct labor cost. It can be considered total direct labor hours. It can be considered total machine hours. There's a number of different bases that can for the rate. But I'm just trying to give you an example of why we're calling this a rate. The rate is a percentage, or I'm sorry, it's an hourly rate, and we attach this hourly rate to the number of hours it takes to finish to create a finished good. And there are three methods to apply factory overhead. One is called the single plant-wide method. The second is called the multi-production department rate method. You'll hear me refer to it as the multiple department method. And the third is called activity-based costing. We know that a product cost includes direct materials, direct labor, and factory overhead. What we're trying to understand in this concept is how do we apply factory overhead to the total product cost? And as I mentioned, those are the three methods: single plant-wide rate, multiple department method, and activity-based costing method. Companies need to select one based on which is the most effective for their company. And this depends on a couple of different things. One is how many products they're responsible for manufacturing. Another is how large their company is. Okay. When we look at those types of things, we can understand which method is the most effective for them. I'm going to be using an example throughout this concept, Ruiz company. This company manufactures snowmobiles and riding lawnmowers. That is their company. That is what they manufacture. And I'm going to be using this example for all three methods to show you how to calculate the difference between the three. The single plant-wide rate method is the easiest one to use, the absolute easiest. I will also say it is not the most accurate, and I'll show you why. Okay, looking at our example, we have a total annual budget of factory overhead of $1.6 million for the year. We expect that we will use 20,000 direct labor hours total for the year. And we have some data. We plan to build 1,000 snowmobiles and 1,000 riding lawnmowers during the year. We anticipate using 10 labor hours per unit, which means we have budgeted 10,000 total labor hours for the year for both snowmobiles and riding lawnmowers, for a total of 20,000 labor hours for the year. Now, using the data to calculate the single plant-wide rate method, which again is the easiest one, we simply take the total budgeted factory overhead divided by the total budgeted allocation base. And you heard me say the word allocation base earlier. I probably refer to it as an activity, right? And this activity based on labor hours. So total budgeted plant-wide allocation base would be the labor hours. So, and again, easiest one to do. It could be direct labor dollars, machine hours, labor hours. We typically use labor hours for this rate, but some companies decide to use other bases. Depends on the company, right? Depends on their mission. For example, if there's not a whole lot of labor and they use more machines than anything else, then they'll use machine as their allocation base. Okay, so here's the calculation. Very, very simple. Factory overhead, 1.6 million divided by 20,000 labor hours. 1.6 million divided by 20,000 labor hours is $80 per hour of factory overhead allocated to each unit produced. How do we allocate it to each unit produced? Well, if it takes 10 labor hours to produce a single unit, and we know that the factory overhead single plant-wide rate is $80 per direct labor hour, 10 times 80 is 800. So the total factory overhead applied to each unit produced is $800 using this method. I could already hear you. Oh, Dr. B, that sounds like a lot. Yeah, it's a lot. It's high. That's a very high overhead rate. But again, this is the simplest method. And so we see a lot of small companies that don't make a whole lot of products use this type of method. Is it the most accurate? No, no, it's really not. But we can see the application. So again, the formula for single plant-wide rate method, you take your total factory overhead budget divided by the total activity base. I'm sorry, allocation base. In our example, labor hours for the year, and that will give you your overhead per labor hour for the year, or per hour for the year. And we take the overhead per hour for the year, multiply that by the number of hours it takes to complete a unit, and we apply that overhead to each unit. Make sense? Questions so far? Are we okay? Good, right? All right. This is the foundation for activity-based costing. So once you understand this concept, the rest of it becomes very simple. Okay, advantages. It's easy to use. Challenges, not the most accurate. And it doesn't work well for companies that manufacture many products. Yeah, it says it's the same across products, which is never the most accurate. Because we know that products take different hours, they take different methods to manufacturing. Especially when we're talking about lawnmowers and snowmobiles, because we know that the way that the hours are allocated are going to be different. Although they both take 10 hours to create a single unit, that 10 hours is going to be devised differently, which we're about to see through the multiple department method. In the multiple department method, this is the second model. So the second method for applying factory overhead. The multiple production department factory overhead rate method, multiple department method is what I'm going to call it, okay? Multiple department method, we allocate the overhead based on each department rate. Each department rate, okay? So the way that this works is instead of the entire company having a single rate for overhead, each department within the manufacturing will have its own rate of overhead. And you'll see that this method is going to be much more accurate. So what we learned about earlier is the single plant-wide rate method. It's one rate for the whole company. Using the multiple production rate method, we have individual rates for each individual department. As we are manufacturing, in our example, as we're manufacturing snowmobiles and riding lawnmowers, in the manufacturing process for each type of product, we have two different departments that do that work. We have the fabrication department and the assembly department. Fabrication is the metal fabrication. They're molding the metal to create the body of the device, of the product. And the assembly department, they are putting together the engines, the mechanicals, the etc., right? And so each department has its own factory overhead rate, and we apply each rate to the finished good. Now, how does it work? Okay, so as you know, the total company has $1.6 million of factory overhead budgeted. The company has allocated a portion of that $1.6 million to each department. $1,030,000 to fabrication and $570,000 to assembly. That's, hey, I didn't make this up. The company decided to do this. I don't know if well, it depends, right? It depends. Depends where most of the time is needed. Okay, so here's how it works. As you recall, it takes 10 hours to create one product. We have $1.6 million, 1,030,000 fabrication, 570,000 for assembly. We earlier on in the example, I had said that the company has designated 10,000 direct labor hours for the year for each department, fabrication and assembly, 20,000 hours total. Yeah, 20,000 hours total. I'm sorry. So here's how it works. You take the budgeted factory overhead for that respective department and divide by the direct labor hours for that department. So 1,030,000 divided by 10,000 is $103 per hour. 570,000 divided by 10,000, $57 per hour. Now, what do we do from here? We can see how long it takes for each product to go through the process, the manufacturing process. Fabrication department for snowmobiles, 8 hours, 2 hours for riding lawnmowers. Assembly department, 2 hours for snowmobiles, 8 hours for riding lawnmowers. You take your $103 for fabrication, multiply that by the 8 hours for snowmobiles, and that's what it is for snowmobiles for that department. You take your $57 per hour assembly times the 2 hours for snowmobiles, and then, of course, you add them up. So here's how it looks. For snowmobiles, 8 hours fabrication, 2 hours assembly, $103 times 8 is $824. $57 times 2 is $114. We add your $824 plus your $114 to get you factory overhead per snowmobile, $938. You follow that same process for each product the company manufactures. So company also manufactures riding lawnmowers. The total factory overhead per riding lawnmower is $662. Now, when you compare that to the single plant-wide rate method, which what was that, $800 a unit, we can see that $938 for snowmobiles and $662 for riding lawnmowers is much different than $800 for each one, right? So what that tells us is that it's clearly more efficient for allocating factory overhead through the multiple department method. Now, here's a term. Here's a new accounting term that you may not have heard before. Hopefully you have, but some of you may have not. It's called distortion cost. Distortion. The word distortion means difference. Well, in very basic terms, distortion means difference. It's the difference between what is perceived and what it actually is. Distortion. Yeah. I'm sure there's probably a bunch of other definitions, but that's what distortion is in accounting, is the difference. So we can see the difference in the allocation. $800 single plant-wide rate method, $938 multiple production method for snowmobiles. That's a difference of $138. Same for riding lawnmowers. $800 single plant, $662 multiple production. That's $138 difference. We can see based on this difference, the multiple production department method is the most accurate. Well, the second most accurate, I'll say. The first is going to be activity-based costing, and we'll talk about that. But the concept of this distortion cost is we look at the differences between the two. And we can see that based off of that difference, snowmobile is under allocated factory overhead by $138, and the riding lawnmowers are over allocated $138 factory overhead. It's under because for the snowmobiles because 938 is different than 800, but it's over, right, by 138. And riding lawnmowers are under by 138. And when that type of distortion occurs, it causes a couple of different errors, really, because it shows us the difference. If we went with a single Plantwide rate method and just kind of disregarded the multiple production department method, I'll end up under allocating or over allocating factory overhead to each unit. And as you would think, that will cause problems for pricing, right? And so with problems with pricing, that just kind of makes life a little bit more difficult. So we can see the difference, what happens with cost distortions, planning, design, and quality are affected, and it causes differences within the factory overhead rates for departments. The differences also cause issues within the ratios, and so that's kind of the perplexing part about distortion. So how do we allocate this using a ratio? You might ask. Sometimes you might not ask. But we can look at how time is being utilized based off of these rates. Now, you can do that for the two departments, fabrication and assembly, based off of the amount of time that snowmobiles and riding lawnmowers take. So in the fabrication department, we're using a 4-to-1 ratio. And for assembly, it's 1-to-4 ratio. What that means is for snowmobiles, we're using 4 times as much time to produce to produce a snowmobile than we are riding lawnmowers. The opposite is true in the assembly. And what that tells us as managers is we can allocate budgets based off of these types of ratios for time, right? That was kind of what we saw early on. So when distortion occurs, there's 2 conditions that must be true. The first condition is there needs to be a difference in production department overhead rates. The second condition is there needs to be a difference in the ratios for allocation. When those 2 things are true, that is causation for distortion to occur. Meaning there will be an under application or over application of factory overhead to each completed unit, assuming that there's more than one type of unit, right? Okay, so here's my favorite part. This is the third method, and in my opinion, the most accurate method for allocating factory overhead. It's called activity-based costing. Activity-based costing is an alternative approach for allocating factory overhead based on activities. Activities are types of work, actions, or processes involved in the manufacturing. Earlier, I gave examples of this. One would be setups on the assembly line. Another one would be quality control inspections. Another one would be change orders issued by engineering change orders. There's a lot of different types of activities, and let's talk about them. These activities are grouped into things called cost pools. And cost pools, the word pool means we group like costs together. And these cost pools will include things like machine usage, inspections, moving, production setup, engineering activities. They're like what we call like activities or like costs. Those are also called cost pools. That's where we group like costs together. And this is, of course, different than the department rate method. Department rate method, as you know, we identified an overhead rate for each department. When we discuss activities, we develop the overhead rate based on each activity. and allocate it to the total cost of the product for overhead. There are two types of activities, I guess we could say. There are core activities, and I don't want to use the word secondary. There are core activities and derived activities. Okay. Core activities are the core of the activity, right? In our example, fabrication and assembly, which are two activities, they also happen to be departments, but they're two activities that make up the bulk of all activity for the company. That's why we call it core activities. And then we also have, I guess, sub-activities, derived activities. We have setups. That's a setup of the assembly lines or the machines. We have quality control inspections. That's when we break down on purpose. We break down a completed unit and rebuild it. When that happens, that's called quality control inspection. They're seeing the overall quality of the build, right? And the third activity is called an engineering change. Engineering change is where somebody at Apple says, hey, let's create this thing called the iPhone 21 from the iPhone 20. And the difference is an upgraded camera or something along those lines. The engineers at Apple who are responsible for the iPhone issue what we call an engineering change order. And what that does is it informs the company that they're going to try to create the next generation of product. That's what an engineering change order is. So core activities, we have a budget, 600,000. Our derived or secondary activities, 1 million, giving us our total $1.6 million overhead budget for the year. Fabrication, we've allocated 530,000 for the year, 70,000 for assembly for the year, 480,000 for assembly, 312,000 for quality control, 280,000 for engineering. How do we find the activity rate? Activity rates are derived based off of each activity. To find the activity rate, we take the budgeted activity cost divided by this thing called the activity-based usage. Activity-based usage. Activity-based usage, again, could be something like machine hours, labor dollars. It's the base, activity base, the usage. Typically, labor hours is, well, it could be more than one, and it's not just one, right? Labor hours for one activity. Another activity could be number of setups. Another activity could be number of quality control inspections. Another activity base could be number of engineering change orders, so forth and so on, right? Okay, so looking at our example, for the year, we expect to produce 1,000 snowmobiles, 1,000 riding lawnmowers. Each snowmobile will require 100 setups, 100 inspections, and 12 engineering change orders throughout the year, estimated. The riding lawnmowers, we expect to produce 1,000 units. Will require 20 setups throughout the year, 4 inspections, quality control inspections, and 4 engineering change orders. So now that we have an understanding of the base, the usage base, we can begin to identify the rate. Okay, so looking at this data, 8 hours for fabrication, 1,000 hours for production, that's 8,000, so forth and so on, 10,000 for snowmobile total, 10,000 for riding lawnmower total. We already knew that. That was from our earlier part of our example. So let's break it out by activity. Fabrication, snowmobiles, 8,000 hours, 2,000 for riding lawnmowers, 10,000 direct labor hours total. For assembly, we've allocated 10,000 direct labor hours, 2,000 for snowmobiles, $2,000 for snowmobiles and assembly, $8,000 for riding lawnmowers and assembly, 10,000 hours. For setups, 100 setups for snowmobiles, 20 setups for riding lawnmowers. It's a total of 120 setups. We have a total of 104 setups for the company for the year and 16 engineering change orders for the year. So what we do is we take the budgeted activity cost divided by the activity-based usage. So what that tells us is for example, in fabrication, 530,000 allocated divided by 10,000 labor hours, it's 53 direct labor hours per $53 per hour, $7 per hour in assembly, $4,000 allocated to each setup, $3,000 allocated to each quality control inspection, and $13,000 for each engineering change order. Now that we've identified the activity rates, we can now look at the activity overhead allocation. For the activity overhead allocation, we take the activity-based usage times the activity rate. Activity-based usage times the activity rate. And then, after we find the activity overhead allocation, we can then find the factory overhead cost per unit. Cost per unit, of course, is the sum of each individual activity to build one single unit. And the way we do that is we take the total factory overhead cost divided by the number of units estimated of production. So using our spreadsheet, activity-based usage times activity rate gives us the activity cost for each activity. And you go down through each activity, and then once we've done that, we can add them all up. 1,294,000 total activity cost for snowmobiles. We do the same thing for riding lawnmowers. 306,000 for riding lawnmowers. Then we take that total factory overhead cost for each product type, divide by the number of estimated units of production. We said we're going to produce 1,000 in the year for each type. And that gives us $1,294 of factory overhead for each snowmobile produced, and $306 for each riding lawnmower produced. We can compare, ultimately, and this slide just kind of recaps the allocation for each activity. We can compare that activity-based costing method to multiple production department rate and single plant-wide rate through distortion. We see 1,294 compared to 938. That's much higher for snowmobiles. And riding lawnmowers 306 compared to 662, much lower for riding lawnmowers. What does this tell us? What does this tell us? Well, it tells us a couple of different things. It tells me that the single plant-wide rate method is the most inaccurate method because we're indiscriminately applying the same rate to all products. It tells me that if I utilize single plant-wide rate method, I would understate my factory overhead by $494 for snowmobiles and overstate it for $494 in riding lawnmowers. What does this cause? What happens, these distortion costs? What happens when I distort it like this? For snowmobiles, if you understate factory overhead, it will result as an increase in sales. A decrease in sales if you overstate factory overhead. what ultimately happens from that is we would not expand production. We would stop production of certain products. And that type of decision based off of the allocation of factory overhead can be very detrimental to a company. And that's why single plant-wide rate method is not very efficient. And we can see that the most accurate method out of the three is activity-based costing because it results in more accurate product pricing and leads to better decision-making. And that, my friends, is the concept of activity-based costing using probably a pretty good example and comparing it to the other methods. Any questions on activity-based costing? Anything that you hope we would have covered but did not, or anything at all, really? Everyone's good? Sorry, we went 7 minutes over. But I'm glad that we got this session in. You're good, James? Okay, wonderful. Santa, are we okay? Paulette?
Yes.
All right. Thank you, Santa.
Thank you so much, Dr. B.
Hey, my pleasure. Anytime you need me, I'm here for you, okay? Brandon.
All right, thank you.
Thank you. Brandon, we're doing okay?
Doing good. Yeah. Sorry, I missed the first
It's
part.
okay.
Everything's
Hey,
good.
no worries, my friend. I will make sure that the recording gets posted to the classroom as always. It'll end up in the discussion area. And if you have any questions along the way, feel free to shoot me an email, call me, set up office hours, whatever you need. Okay. Well, thank you all so very much for your time today. I appreciate all of you. If you ever need anything, you just shoot me a quick note. You call me, set up office hours, whatever, and we'll work things out, and I'll be happy to help you out in any way that I can. Keep up the wonderful work in the course. You're all doing very, very well, especially as it comes to those fun homework assignments and exams. Overall, the course, the entire class did very, very well. Just to kind of recap what's going on this week, you have a discussion and you have a homework assignment. So it's very straightforward. Should be a very straightforward week for you all. And the 10K project seemed to be going pretty well, and I'm enjoying the discussions. I'll have all of the grading completed here in the next few days. In the process of moving, so just be a little bit patient with me if you don't mind as we go through the grading. So anyway, if you ever need anything, just get a hold of me. I'll be here for you. And thank you all so very much for your time, and enjoy the rest of your morning, day, evening, wherever you may be. And you know what I'm going to say, right? Stay safe, wash your hands, and do the right things. Thank you all so much. Take care, y'all.
You too, Dr. B. Bye-bye.
All right, bye-bye. Take care.
Bye.
Bye. Catch you later. Take care now.